Good evening. Trying to get some tea time back in. I've been considering how computation and design have come back to it. It's 2024, and I really think that it's really about that. That's how I kind of got started. I was computational first, computer science, and I switched to design. That was awesome. Then it came back to computers again, the two together. It's early 90s. And now, years later, wow, 30 years later, I'm here at the intersection of design and computation again. Full circle. So, what is design is something that you may be wondering about if you're not a designer. It really is a cultural muscle. It isn't something that you learn from a book per se. You have to see a lot of examples. You have to actually build and create. It is literally something you do learn over time by making a lot of mistakes. We know in this age of large language models, we talk about evals, and you have to evaluate the output so you can correct the output over time. If you want to become a designer, same kind of thing. You start making stuff. I made name cards for a while, business cards for a while, chopstick wrappers, stickers, anything, just to get started. That was in print, of course, and designing for print is great because you get to finish something. I find that designing for the web is tiring because you're never done. But I guess that's why it's such a cool era, an era of digital products. I think that design definitely is not just graphic design, it's industrial design, it's architectural design, it's landscape design. All kind of designs in there. There's classically minded design that, if you've ever been to Greece, visited the Parthenon, or if you ever looked at just paper sizes, European paper sizes are beautiful. If you take a European piece of paper, an A, whatever, B, whatever, I'm going to draw a diagram on there for you if I can. Hold it there. It's a square, and you just extend the line, and you get a circle called a root 2 rectangle. Beautiful rectangle. The design's old beauty. Leans towards mathematics sometimes, and leans towards intuition, feel, rhythm of society. That's design. Computation used to be easy to understand. Well, it was hard to master. But now we have GitHub Copilot, Engineer, GPT, whatever, Cursor, all these cool tools that program for you. So being computational isn't just about programming anymore. It's about kind of like design. The ability to make, create, make mistakes, discover, get a power assist from AI sometimes. It's about non-deterministic computing. Just today I was building something with GPT-4o and I thought I figured it out, but sure enough, I got some deviations from the norm that I wanted, and so I gotta build an evaluation test to be able to figure out how to correct it. You can correct the LLM going in, you can change what you set into it. That helps sometimes. Or you can correct what comes out of it. I love how everyone's discovering that if you take what comes out of it and use the deterministic system to understand was it right or wrong. Like if it generates JavaScript code, does the code compile? That's good. So having ways to sort of test things with real instruments versus just more AI to test more AI. It's this boundary between the old way we did things and this new way we do things with LLMs. Very confusing. It's very exciting. Now, Design and computation, putting the two together. What a great time. Because design has a lot of meaning in it. If I remember when I was president of RISD, Rhode Island School of Design, I noted how the liberal arts was core to the education there. Same as MIT. MIT has a liberal arts requirement. We call it humanities there. Design schools that require liberal arts, design departments that require liberal arts. It's good for you because you understand why we make things, the setting for it, the history of it. The history not just of design, but the history of society. The reason why we're here. So that knowledge, interestingly, is deeply embedded in these large language models. So it knows a lot of culture. It knows a lot of history. More history than I do. I'm sure you've heard of small language models making the scene. It's pretty cool. You can run them on your computer. Not bad. They're not as smart as the big ones, but people argue that we'll just get smarter, or you can run multiple small language models together, and together they're just as good as a big large language model. Kind of like transformer robots, they all connect together. Actually, transformers, those robots don't connect together, more like Voltron. Japanese robot dynasty has a lot of sort of little robots becoming one big robot. Great toys, by the way. So, this is my blah, blah, blah. You had some tea or coffee, whatever. Design and computation. Culture underpins it all. Large language models are sitting at the base of that. The way we did things is going to change. And it's an exciting time. So I hope you're writing code as much as possible. I think prompting is one thing, but do this semantic coding together with conventional coding. Pick up a language like TypeScript, Python, C#, Go. My gosh, there's so many languages out there. And combine them with the large language model of your choice. This combination together. Yummy. Well, have a good evening or good morning or good afternoon there. Thanks for tuning in. Cheers.